Okay. And how are we going to find out the inverse function? For the inverse function, for example, this one, y equals radical x minus 2. What's the inverse of this one? Before we do the inverse, let's find out the domain. The domain for this one is x greater than 2. It's because x minus 2 cannot be negative. X minus 2 is no negative, and if we add 2, you cancel positive negative, so x is greater than 2. Okay, so the domain is 2. What is the range? The range is y greater than 0, this one. Because any value you put here, you choose the square root, you always get positive. Okay? So that's why we say the range for y is greater than 0. Okay. Now, you may draw the picture for y equals radical x minus 2. So right here, let me put a in order to draw this picture, you want to choose different values. Okay, if x equals 2, then you plug in 2 here. 2 minus 2 is 0. Radical 0 is 0. And then 3, input here. 3 minus 2 is 1. Radical 1 is 1. X, choose 6. You input here. 6 minus 2 is 4. Choose radical sign. You have a 2. So 6, you get 2. Put 11 here. 11 minus 2 is 9. Choose radical. Then you have a 3. Okay, so x is 11, y is 3. Now is that you have a x 2, 0, y is 0. 2, 0 is right here. X is 2, y is 0. 3, 1. 3 for x, y is 1. Okay, so this is the point. And then 6, 2. X is 6, y is 2, so it's this one. X is 11, y is 3, so 11, 3, right here. So you have 4 points. You can use a smooth line to connect it. That would be the curve for y equals radical x minus 2. Okay, so you may put y equals radical x minus 2 here. Okay, now our business here is to find out the inverse. Okay, that means you want to find out the expression to go back from 0, go back to find out 2, from 1, go back to find out 3, from 2, go back to find out 6, from 3, go back to find out 11. You want to find out that expression. How? 2 steps. Step 1, solve for x. This is the given one. Okay, this is the given one. Now, in order to solve for x, we need to isolate x. We are given y equals radical x minus 2, square both sides. Then you have a y squared. And here you square this side, it's going to be x minus 2. Okay, add 2 on both sides, cancel this positive negative 2. You have a y squared plus 2 on this side, and then you have a positive negative 2 cancel each other, so x left alone. Now that's step 1, solve for x. Step 2, exchange x and y. Now that's easy. Here is x, replace x by y. and here is y. Replace y by x. So this is the final solution. So we have found the inverse function of this one. Is this really the inverse? Look, you want to import 0, 1, 2, 3 to check that if you can get 2, 3, 6, 1. If we input 0 here, 0 squared, 0 squared plus 2 gives you 2, because 0 squared is 0. So you input 0, you do get 2. That's 0, 2, you find out. Okay? And then you input 1 here. Do you get 3? From 1 you get 3. For sure. 1 squared plus 2 is 3. 2 plug in 2 squared is 4 plus 2, you have 6. 3 input, 3 squared is 9 plus 2 is 11. So from 3 you do get 11. Okay, so you input your x, you have your y. So this will be the inverse for the function y equals radical x minus 2. Now, let's see the picture of this one. Remember, here is our x. Input, here is our x. So 0, we have 3, that's for y. So 0, 2. Okay, x goes first. 0, 2. 0, 2 is somewhere where? Right here. Okay, 0, 2. Here is 0, 2. So it's this point. X is 1, y is 3. So 1, 3. So 1, 3. That's this point. And then x is 2, you have a y, 6. So 2, 6, right here. And x is 3, y is 11. So 3, 11. Okay, so this is our x. Remember the first one. Now you can see, connect all those 4 points. That would be the graph of this inverse function. And then look. Here is 2, 0. Here's 0, 2. Here is 3, 1. Here's 1, 3. And here's 6, 2. Here's 2, 6. Here's 11, 3. Here's 3, 11. And then you can see this graph and this graph. Two graphs are symmetric with respect to the line y equals x. So that's important. Yeah, that means if you flip this line based on this curve, you'll get this part. Okay? But remember, if you draw y equals x squared plus 2 from your calculator, you actually get a parabola. This left-hand side, the dotted line, shows up. We know this is a parabola. Okay? But you know, if you consider the negative side, then this picture, this function will not be the inverse of this one. So in order to be the inverse, remember, the domain and the range must be exactly opposite. Okay, you can see right here, you have x greater than 2. Now, what is the range? Whatever you input here, you got a positive. Positive number because this is squared. Okay? You put negative in x, you get positive. You put positive, you get positive. So this is a positive number plus 2. You plug in 0, squared, you get 0. So this right-hand side is always greater than 2. That's why y is greater than 2. So that's why you see they're exactly opposite. And then this was the domain. This is the range in the inverse function. Previously, we have a range is greater than 0, okay? Because this y is not negative. It's greater than 0. Then the domain has to be greater than 0. Even you put negative number inside, makes sense here, but if you consider the negative part right here, it's not going to be the inverse of this function. Okay, so in order to be the inverse, x must be greater than 0. So that's why we only consider this part. Okay, we say the domain of this one greater than 0, then this function with domain greater than 0 will be the inverse of this one with domain x greater than 2. Okay, so this example basically shows us that how to find out the inverse. That's point 1. Point 2 is that the two graphs are symmetric with respect to y equals x, this line, this dotted line. Remember, for the inverse function, don't consider the left-hand side for this case, okay, with this given equation. Please review this lecture. I will see you next time.